and welcome to StatLab StatCrunch videos. Today's section is section 6.1. Before I start this section, I really suggest you all reading the textbook for section 6.1 as it deals with intervals and confidence intervals. It kind of slightly might be confusing because we deal with interval estimate, confidence intervals, and critical values. So you need to have a good knowledge of what that is before you start looking at how to solve these problems. Now, having said that, let's go ahead and jump into problem number 8. This is where you will be starting your homework problems. I have deleted the first 7 problems and a couple of other problems which you might not need for this semester. Graph the interval 8 plus or minus 7 on the number line. So they're telling you graph something that starts at, let me click this one, that starts at 8 and plus 7 and minus 7. So 8 plus 7 will give you 15, right? And 8 minus 7 will give you 1. So your interval should be 1 to 15. Very good. What do they say? They say include the endpoints. So when they say include the endpoints, you should have brackets. You should have brackets and they should be from 1 to 15. Because your 8 is all the way in the middle, you're going 7 up and you're going 7 down. So let's go ahead and see which one is that. Definitely not the first one because it's a bracket, so it's a parentheses. Not the second one because it's a parentheses. You only have option C and D. And if you look at it, option C has negative 8. I'm starting at positive 8. So definitely my answer is answer D. So let me go ahead and click that and then check my answer and voila, there I go. Okay, the next one says does not include. I will let you all go ahead and work on this one. So when it says does not include, you will have parentheses, not brackets. Include is brackets, does not include is parentheses. All right, so problem number 10. Before I start this problem, I want you all to take a pen and paper, start writing down the steps. Here, they're asking us to find critical value, which is your ZC. So to find your ZC, the critical values, they have given you the confidence interval. The confidence interval is 87. What does that mean? So you're 87% confident. So that means 87%. Remember percent, area under the curve, they're all the same. So you're 87% confident. So area under the curve is 87. And they want you to give, let me change the color here. And they want you to give the Z values for 87%. Let's go ahead and do that in StatCrunch. Question help. StatCrunch. Are you writing this down? Stats, calculators, normal. Once I have my stats, calculators, normal, I click on between. Stats, calculators, normal, and between. And what do? I simply take my 87%, or which is 0.87 in decimal, and plug it in the area right here. Let me go ahead and do that. Point, do I have a point there? Yes, I do, 87, and compute. So now you see you'll have two values. One is a positive, one is a negative. But what you have to do is you only plug in the positive value here. You don't have to plug in the negative value. So if I plug in positive to 2 decimals, 1.51. 1.51. And check my answer. There you go. Now let's move on to the next one. So the next one here, let me expand this. The next one here is find the margin of error for given values of C, standard deviation, and N. So let me go ahead and write down. But before you do that, let me click here. You see what they give you here? They says click on the values for critical value. So if you're 90% confidence, your critical value is 1.645. If you're 95% confident, your critical value is 1.96. So if you're 99% confident, your critical value is 2.575. Okay, so I am 95% confident here. So critical C stands for your confidence interval. C is your confidence interval. So, or level of confidence sometimes. And so if you're 95% confident, so the area under the curve is 9.95 and the respective Z values are 1.96. Okay, I'm going to go ahead and work with the problem now. I'm going to click done. The formula for E is ZC, standard deviation, over square root of N. So your ZC value, we just saw that from the table, which is 1.96, right? And my standard deviation, you see that my standard deviation is 3.5. So times 3.5 over square root of N. Remember, the N is your sample size, and your sample size should always be greater than 30. So square root of 64. So let me go ahead and see if I have a Desmos open. Yes, I do. Okay, so 1.96 times 3.5 over 64. So let me go ahead and clear my Desmos. 1.96 times 3.5 divided by square root of 64. Let me expand this one too for y'all. Oops, that's way too much. Okay, so it's 0.8575. Let me copy this just to be on a safe side. And when I move to I'm gonna plug this here, round to 3 decimal places. So it is 8.858. Check my answer. Fantastic. Let's move on to the next one. Okay. Construct the confidence interval. Please keep in mind, every time you see the word confidence interval, so it is telling you you have to give me an interval. That means you're going to give me a lower limit and you're going to give me an upper limit, the interval estimate. Okay, so that's what confidence interval means. So what you're trying to tell me is, remember when you take a sample, and let's say I want to find the average height of a TCC student. I take a sample and I get a mean. And I cannot say, let's say my mean is 5 foot. I take a sample of 40 students and I get a mean of 5 foot. I can't say with 100% confident that my entire TCC has an average height of 5 foot. But what do I say? I say, you know what? Because I got 5 foot, I'm going to give them an interval. I'm going to say 90% of my students will be from the range of 4.5. I'm just giving you random numbers here. 4.5 to 5.5. Because I got 5 foot as my mean, I want to make sure I include my sample mean in the middle. So I go 5 below, I go 5 above. Okay, so that's just an example. So let me erase this and start with the problem. So then when they say confidence interval, you know you have to give them a lower limit and upper limit. How confident are you? You see the C value, that tells you how confident you are. You're 90% confident. So let's go ahead and use StatCrunch. Have your pen and paper ready? If not, pause the video and have it ready. StatCrunch. Be very careful here because we're going to be looking into a whole different statistics. Stats, Z-stats, oops, never mind, stats, Z-stats, one sample with summary. Let me expand this. I should have done that before. Stats, Z-stats, one sample with summary. Okay, first thing first, you will go ahead and plug in your mean. Let me expand this one so you can see what the mean is. Okay, you should be able to see your sample mean. My sample mean is 6.3. Do you see that? X bar is your sample mean. Standard deviation is this symbol is standard deviation right here, 0.7, and sample size n is 43. You're going to scroll all the way down and make sure you check the confidence interval. And what you have to make sure is the confidence interval matches. This does not match, so I have to go back and change it. So I'm going to change the confidence interval to 90 and then click compute. Once I have this, I'm going to go ahead and copy my lower limit and upper limit. So your lower limit, you will copy your lower limit and place it right here. And you will go back and copy your upper limit. Remember, you're giving me an interval and you will place it right here. And now they said 2 decimal places. So I don't need all of the gone. And let's see, 4.8 is my, and then you'll click. So the common rule of thumb is if your mean is 6.3, let me check this one. If your mean is 6.3, oh come on. If your mean is 6.3, then your confidence interval should be pretty much in that range. If your mean is 6.3, you can't say your interval is, 25 or 75 or something like that. It has to be pretty much in that range. So I'm simply going to go ahead and check my answer, and that is fantastic. Now let's move on to the next one. What does it say? Find the minimum sample size. Very good. So minimum sample size, the formula is n equal to ZC, standard deviation, over E n whole square. Okay. So what are they telling me? Find the minimum sample size that is required to estimate a population mean with given confidence. So they're telling you, hey guys, what should be my sample size when I want to be 98% confident and my standard deviation should be 8.4 and the margin of error should be 1. So when you say margin of error should be 1, what that means is, let's say your mean is 4. Your margin of error is 1. That means your upper limit is 5 because 4 plus 1 is 5 and 4 minus 1 is 3. That's a 3, guys. Yeah. So your error is 1. Okay, so that's what they want. I'm just giving you an example, but let's go ahead and see what our answer is. Ooh, did I delete everything? Okay. I have to go back and do that again. So my n is ZC, standard deviation, over E n whole square. That is a 2. Oh, come on. That is a 2. Okay. So I'm going to go ahead and find my, remember I have C. How do I find ZC? I'm going to come back to that in the end, but I'm going to go ahead and plug in my standard deviation. My standard deviation is 8.4. And my error is 1. And remember, I have to find my ZC, so I'm going to wait to find my ZC. How do I find my ZC? Let me see if my StatCrunch is open. So what I'm going to do is I'll have to unclear this one so I can get to my StatCrunch. Remember, I'm trying to find my ZC. So how do I get to ZC? I will unclear this. I go to stats, calculators, and normal. Remember to find critical values, you click in between. And you're 98% confident, so area under the curve is 98, and I compute. So my critical value here, ZC, is, where's my pen? It is 2 point, oh, come on. It is 2.3263. So I'm going to go use those values. Let me write that down before I forget. I'm using a pen and paper here too. I'm solving the problems while I record it. So it's 2.3263. Okay. So I'm going to unclick this one. So my Z is, remember how I found out my Z value? I went to StatCrunch, calculators, normal, between. So I got my ZC. Remember guys, your C is not your ZC. C is just the area under the curve. Your ZC is your respective Z value. In my case, which is 2.3, that is a 3, I swear, 263. I'm just going to leave it as 26 times, what is my standard deviation? 8.4. I hope you wrote down the formula because I'm not going to write it again. This is a 4, trust me, over 1. And remember, I'm squaring everything. So I'm going to go ahead and put this in Desmos for you so you can see. And then I'll plug in the answer. Okay, where is my Desmos? Oh, no, not this. Yeah. So I'm going to go ahead and clear this. My Z value, clear everything, clear all. My Z value is 2.3263 times my standard deviation is 8.4 divided by 1, right? And once I have it, what do? I square everything, correct? So I'm going to simply go ahead and square it. So it's 187.5. So let me go ahead and copy this one. I'm going to go ahead and plug this in here. So they're asking me to round off to the nearest whole number. So I can't give them in decimal. So I always have to round up. So 188, check my answer. Oops. Let me see, what did I put my, let me see if I have this right. Oh, never mind. It's 2 point. Okay, now square this. 381.8. Okay, so I plugged in my z-score as 22. So please, please, please don't make those mistakes when you're doing it. Let me clear this one. Control V. They're asking me to round off, so I'm going to move to the next whole number and then check my answer. There you go. So I accidentally put my z-score as 22 point instead of 2 point. All right, so moving on to the next one. So when you do the previous problem, it's always nice to have, what do you call, a pen and paper handy. So for the next one, they said use the confidence interval to find the estimated margin of error. Let me see if I can pull up my paintbrush here so it's easy for me to write on it. Paint 3D. Okay, I'll have it here, a new one. Okay, I'm going to keep this here. No, that's not what I want. Okay. A biologist reports a confidence interval of 3.8 and 5.4. Okay. When estimating the mean height in centimeters of a sample seedling, they're asking us to estimate margin of error. So when you take a sample and when you calculate the mean, the concept here is, where is my paintbrush? The concept here is you give them the lower limit, you give them the upper limit so that your mean is exactly in the middle. Okay, so let's see what he gave. He gave me the lower limit is 3.8 and the upper limit is 5.4. Okay, the upper limit is 5.4. So when I draw it on the number line, it's exactly in the middle. So how do I find, this is my 3.8. Do you see that? This is my 3.8 and this is my 5.4. How do I find this distance? So how do you think I can find this distance? You simply subtract 5.4 minus 3.8. So 5.4 minus 3.8 is 1.6. So the margin of error is from your lower limit to your sample mean or from your sample mean to your upper limit. So this distance, the gap between your mean and your lower limit, your mean and your upper limit is your error. Okay, but this entire distance is 1.6. So what do I do? How do I find half of it? So each one is going to be 0.8 and 0.8. Do you see that? So I'm simply going to go ahead and plug in. So my margin of error is 0.8 and check my answer. Very good. Now what's the next one? They're asking me to find the mean, the sample mean. That is very easy. Once I have my margin of error, I simply take my margin of error and add it to the lower limit. So I can get my sample mean, which is x bar. Remember, sample mean is always in between. And this distance is 0.8. So 3.8 plus 0.8. So let me go ahead and do that here. 3.8 plus 0.8. And that's going to give me 4.6. So my sample mean is 4.6. And check the answer. Well done. So let's go ahead and look at the next question here. Just to avoid confusion, I had checked show complete problem here. You are given a sample mean and population standard deviation. Use the information to construct 90% and 95% confidence interval for the population mean, and I should also interpret the results and compare the widths of the confidence intervals. For a random sample of 37 business days, the mean closing price of a certain stock was $113.21. Assume population standard deviation is 10.56. How do I find the interval, confidence interval? StatCrunch, right? And I go to stats, ZStats, one sample, and let me expand this. Oh, I should have done that before. Stats, ZStats, one sample with summary. And let me make sure I have all the information. Do I have my sample mean? Yes, I do. So this is check. Do I have standard deviation? Yes, I do. Do I have sample size? Yes, I do. So let me go ahead and plug that in. I'm going to leave it here so you can see. 3.21. Standard deviation 10.56. Sample size 37. Did I plug the right numbers in the right place? Let me cross check because sometimes, yeah, I did. And then remember you have to click confidence interval, not the hypothesis. That's the one that's defaulted. And my confidence level is 90%. So I'm going to go ahead and change 90 and compute. Once I have that, do you see here? Your lower limit is right, and your upper limit is exactly what it's supposed to be. Remember, confidence interval by itself means you're giving me a lower limit and upper limit. All right, all right. So let's go ahead and look at the next one. So the next one is pretty much the same, but the confidence interval is 95. So what I have to do is I will simply go to options, edit. Everything stays the same, but instead of 90%, what am I doing? 95%. And compute. And let me see. If I have 95%, so it's 109 and 116.61. So if you look at it, your 95% confidence interval, the range is from 109 to 116. For your 90% is 110 to 116. So if I graph it on the number line, you have 110 right here and 116 right here. I'm going to change the colors for 95%. 95%, 109 is before 110 and 116.61 is after 106. So you see that 95% is wider than 90%. So let's go ahead and see the next question. So definitely 95% area, because area under the curve, 95 is more than 90%. So let's go ahead and interpret the results. So what does it mean? You can be 90% confident that the population mean price of the stock is outside the bonds of 90% interval, and 95% confident for 95% interval. What does this even mean? Remember, you're not telling me that you are 95% confident that your population mean is in this range. That's not what you're telling me. You're telling me that 90% of the samples will be in this range. So 90% of the samples will contain the population mean. 95% of the samples will contain the population mean. So that's exactly what you're telling me. So when you scroll down here, you can be 90% confident that the population mean price of the stock is between the bonds of 90% interval, and 95% confident for the 95% interval. So you're telling me 90% of the intervals will have the population mean. 95% of the intervals will have the population mean. If this is confusing, please go back and check your lecture notes. Let's go ahead and look at the next one here. Let's see. I'm going to do problem number 17. So if you look at 15 and 17, I want you all to scroll back and forth. 15, you have the summary. 17, you have the data. So everything stays the same, but instead you will open your data in StatCrunch and follow the exact same steps. You will first open your data in StatCrunch, stats, ZStats, one sample. Now it's with data. Let me expand it again. Stats, ZStats, one sample with data. Remember, you have to open the data in StatCrunch first. Variable. And one very, very, very important thing is they will say standard deviation is optional, but you have to plug in your standard deviation. If you don't plug in your standard deviation, your answer will be 1/10 of a difference. I'm circling it so many times, so you write it down somewhere how important it is to plug in your standard deviation. Okay, so let me go ahead and read the problem here. A random sample of closing stock prices in dollars for a company in a recent year is listed below. Assume that standard deviation is 1.78. So I'm going to go ahead, open my data in StatCrunch, here, and plug in my standard deviation. 1.78. Remember, you have to check your variable too. And I'm going to scroll down. Remember, what are you scrolling down to? Confidence interval. Your confidence interval is, first one is 90%, so click 90, compute. And then you see that your lower limit is 19.46, rounding off 19.46. Do you see that? Let me draw a line. 19.46, 19.46, 20.92, 20.92. Now for 99% confident, what do? Same thing, right? Let me close this here. Let me start this from the beginning so you all know what it is. Open your data in StatCrunch. Stats, ZStats, one sample with data. Stats, ZStats, one sample with data. Plug in your variable. Plug in your standard deviation. I don't think I have to circle it again. Scroll all the way down. Check confidence interval. I want to be 99% confident this time. Okay. And then compute. And here you are 9.04, 21.34. Oh, come on, draw this for me. Yeah, 21.34. Okay? Hope this helps.